PSD of the output equivalent to mod h of omega whole square multiplied with PSD of the input. So we can use this relation. So there is a RC low pass filter. So input is the white noise, that the input is X of t, and the output is the random process Y of t. What do you mean by white noise here? Noise is a random signal. So noise can be characterized as a random process. Therefore, we are letting noise is the, so X of t is the white noise. So we will get some output here. That output is Y of t. Here PSD of input is X of t is given as N0 by t. See, interval is not given. That indicates it is constant. Power spectral density is constant for all values of frequencies. So that's why in the previous problem, this interval is mentioned from certain value to certain value. That is minus alpha to plus alpha. It is non-zero. Otherwise, it is zero. But here, no interval is given. That indicates this value is constant for all values of frequency. For all frequencies, that is constant. You have to find what you have to find. Autocorrelation of the input. See the problem. Autocorrelation of output SYY of, you have to evaluate this, this and this. So how can you do this? Is it an LTI system? So this is example of LTI system. Here the transfer function of this particular system is equivalent to 1 by 1 plus you might have derived the transfer function of this RC low pass filter, which is a low pass filter. So we know this h of omega. Can we find this? What is mod h of omega? It's 1 divided by under root 1 plus omega RC whole square. Is it correct? So therefore, SYY of omega is equivalent to mod h of omega whole square, 1 divided by 1 plus is multiplied with N0 by 2. Therefore, this is R so this is complete. Next we have to find RYY of tau. What is RYY of tau? See, we know this. This is the inverse Fourier transform of SYY of omega. That is inverse Fourier transform of N0 by 2 see, we already know that e power minus a mod t Fourier transform of this is equivalent to 2a divided by omega square plus a square. So what is this? Two-sided exponential. The Fourier transform of two-sided exponential is equivalent to 2a divided by omega square plus a square. What is the Fourier transform of e power minus at? 1 by 1 plus 1 by a plus j omega. Now with this knowledge, see what is the inverse Fourier transform of this? This. So we already know that n naught divided by 2, this is 1 plus omega RC whole square. What is this? SYY of omega. See the previous slide. What is SYY of omega? n naught by 2, 1 plus omega RC whole square. Now, you just take that RC square outside, then what you will get? N naught by 2 RC square 1 by RC whole square plus omega square. Can I write this as n naught by 2 into n naught by 2 is a constant, n naught is a constant, 2 is constant, so 1 by RC square divided by omega square plus 1 by RC whole square. So now we have, see, a divided by a square plus omega square, but actually we require 2 here, therefore 2, this will become 2 a we require. So for that we do one thing. Is it right? So now we have 2a divided by omega square plus a square. So therefore, what is the inverse transformation? See, if we have this, we have e power minus a. A is 1 by RC into tau. E power minus 1 by RC tau. Mod tau. We bring this term this side. Then what we will get? 4 RC by n. So what is this now? This is equivalent to, sorry, RYY. See, we started with SYY. Here, RYY of tau is equivalent to 4 RC divided by n naught to e power minus 1 by RC mod tau. See here, if you substitute tau by minus tau, replace tau with minus tau, can we get the same value? So this, the important property of the autocorrelation is satisfied. So PSD of x of t that equivalent to omega is equivalent to n naught by 2. So therefore, Rxx of tau is equivalent to inverse Fourier transform of which is equivalent to so we are taking the inverse transform. So left hand side is function of tau, right hand must be function of tau. So therefore we obtained all the three quantities: autocorrelation of the input, autocorrelation of the output, and the power spectral density of the output. The random process x of t is applied to a network with impulse response h of t. The cross correlation of x of t with the output y of t is known to have the same form. Yes. Find the autocorrelation of y of t. What is the average power in y of t? How can you find the average power? Expectation of y square of t is the average power, or RYY of 0. Try to solve these problems.